Now let's look at promise methods. The real superpower of promises is concurrency. Now, concurrency in programming is the ability of a program to manage and execute multiple tasks in overlapping time periods. So, what concurrency does is it structures our code to deal with multiple things at once. So, often it rapidly switches between tasks rather than executing them simultaneously. But when we're dealing with parallelism, that's when our code is executed simultaneously. But here we're concerned with concurrency. Now, consider a real world situation. Say you're building an app. You don't always want to wait for one task to finish before starting the next. For instance, if you need to fetch a user's profile picture, or maybe their recent tweets, or maybe their local weather forecast. Now, these tasks, they don't depend on each other. So if you were to run them one after the other, then that would amount to a waste of time. Now, for promise methods, JavaScript provides for inbuilt methods to handle multiple promises concurrently. And they all accept an array of promises and return a single promise. Don't forget that. They all accept an array of promises and then they return a single promise. So these inbuilt promise combinator methods, we have Promise.all, so it accepts array of promises. We have Promise.race. So for Promise.all, all must succeed. Then we have Promise.race. It also accepts array of promises. Anyone succeed. We have Promise.all.settled. It also accepts array of promises. It waits for all and then returns success or fail. Then we have Promise.any, which that's first successful. It returns the first successful promise. It also accepts array of promises. So this is useful for parallel request, timeout, batch operations. Okay, so let's start with Promise.all. Let's go back to Visual Studio Code. So we're going to look at Promise.all. Okay. So remember we said our promise methods, they accept array of promises and then they return a single promise. Now, for Promise.all, it executes array of promises concurrently, and then it waits for all of them to succeed, and then returns an array of the result in the exact order that they were requested. Now, there's a catch here. When we implement Promise.all, if one promise rejects, that is, if one promise fails to resolve, the entire operation immediately fails, and then it throws an error, even ignoring any successful promises. So let's look at this code. We have this function fetch tweet, that's the first one, and then it returns a new promise. It takes a callback. This callback takes a function resolve, so this is res, and then it returns the set timeout. Inside our set timeout, we have this callback, and then this callback returns our resolve function, and then inside our resolve we say tweets loaded. Our delayed period is 1 second. So that's for the first function. It returns this promise. For the second function, is known as fetch weather. It returns a new promise. It takes a callback. Inside this callback, we have our resolve function, and then we have our set timeout scheduler function. In the callback of our set timeout, we call our resolve function, and then we pass the string in there. says weather loaded, and then our delay period is 1500. So that's for the second function. The third function is fetch by the API. It also returns a new promise, but this one rejects. So inside our set timeout function, we calling our reject function, and then we're passing this string API field, and then for our delay period is 500. Now let's look at how we might implement Promise.all. Okay, we have this async function. Don't forget what we said about async function. Any function we call inside this environment is going to take await, and then whatever that function has to return a promise, that function that takes await has to return a promise. So we have a try catch. We've talked about this in async await. Okay, now inside here we say okay, console.time. So this is going to be Promise.all time. So this is a string we're printing here. Now we're starting this program. So we have these tweet weather, more like we're doing what is it called? We're doing React. We're using this what is it called now? What do you call this operator now? In any case, we're storing tweet and weather inside here. So we await Promise.all. It takes an array of promises. Don't forget this function returns promises. So it takes an array of promises. Okay, so we get the first one fetch tweets. It resolves, so we don't expect this to fail. The second one is fetch weather. It resolves. We don't expect this to fail. So it is Promise.all. If one fails, everything else fails. So we want to log tweets. So this we store tweet and weather inside this array, and then we're logging weather as well, and then we want to log the time here and here. So if we got an error, remember what we said about Promise.all. If one fails, everything else. So we can get the error here. So I'm going to save everything, and then we're going to go back to our console, and then let's see what we get. Remember, we have to invoke this getUser dashboard function here for this to work. So let's go to our console. Let's see what we get. I'm going to refresh this. Okay, so we get the first one, say tweets loaded, weather loaded, then Promise.all time, that's the script, the JS13. Okay, so that's the console. That's it. This one says the longest promise. It just prints. It logs the results, the time it took for the longest promise to resolve. So that's what we're getting here. 150.2.41 blah blah milliseconds. That's what we're getting here. So the takeaway here is, for when we implement Promise.all, we pass whatever method we're using, we implement, whether it's Promise.all, Promise.race, they all take array of promises and they return a single promise. So here we're implementing Promise.all. The promises we're passing here as an array, they better resolve. If they don't, because it's all or nothing, it's just, if they don't resolve, if one of them should reject, then we're going to get error. But this resolves anyway, so we're good. Okay. There is also another one known as Promise.all.settled. So we're going to implement that now. We'll see how that works. Now for Promise.all.settled, it runs all promises concurrently, but it never short circuits. That is, it waits until every single promise is either fulfilled or rejected, and then returns an array of objects describing the outcome of each. So this is perfect when we say we want to gather all available data, even if some part of the page failed to load. So let's look at how we might implement Promise.all.settled. So I'm going to comment this out. We don't need this anymore. We've implemented that. We want to implement Promise.all.settled. So I'm going to uncomment this. Okay. Now we're passing fetch tweets, fetch bad API inside our Promise.all settled. We're inside async function, and then we're logging this result. Remember, for our Promise.all settled, no matter what, even if one of the promise rejects, we're still going to get some kind of result. So it's going to return the result even if the promise rejects. So if you reject, we're going to get what is it called? The error message. So we don't even need to do the catch. We don't need to catch error here anyway. So here we're passing fetch tweets, fetch bad API. Now in our functions here, fetch tweet resolves. So when we call the resolve function here, we pass this string tweet loaded. When we did for fetch bad API, it doesn't resolve, it rejects. And then inside our reject function, we pass the string API failed. So for Promise.all settled, it doesn't matter whether it's resolves or rejects, we're going to get some kind of result. So I'm going to save this. So we're using await. Remember, when we use await with the function, that function returns a promise. So get complete data, it's asynchronous, and then we're invoking it here. So let's see what we get in our console. Okay, gonna refresh this. Okay, so we get this array of objects. The first one is status fulfilled. The value is tweet loaded. The second one is status rejected. It says API failed, length 2, like that. So you realize that this one, even though one of them rejects, we still get the status for both of our promises. So we're returning a single result. The single result is an array of objects. So we get the status, we get the value. And then, so for status, when the promise resolved, we got a status that says fulfilled. Then the value, which is the string, we pass into our resolve function. And then when the promise, when it rejects, we got a status say rejected, and then the reason, which is the string we pass into our resolve reject function. Okay, so that's that for Promise.all settled. We also have a Promise.race. For Promise.race, the first responder wins. So when we implement Promise.race, the result of the very first promise that settles, that is, that completes, whether it succeeds or fails, whoever crosses the finish line first, that's what wins. So we can think of a classic use case for Promise.race, like say we had in a timeout to a slow network request so that the app doesn't hang forever. So don't forget, Promise.race first responder wins. Where is it? Anyone succeed. So first responder wins. The very first promise that settles or completes. So whether it succeeds or fails, whoever crosses the finish line first. So let's look at Promise.race. Again, I'm going to comment this out. We don't need this. We've implemented this, and then we're going to look at Promise.race. So I'm going to comment this. Now look at this. We have this function download video, and then it returns a new promise. So here we have a callback, takes the resolve parameter, which is a function, and then this callback returns a set timeout. Inside our set timeout, we have a callback. What am I doing here? We have callback, and then we are returning our resolve function, passing the string here, and then the delay period, it's 5 seconds. So that's for download video we also have another one here called timeout. It also returns a new promise, but this rejects, and then for our reject function, we pass a string, and then there's 2000. That's our wait period, our delay period. Now we implementing it inside this async function. So whichever finishes first wins the race. So here we're passing, okay, await Promise.race, and then we pass the first promise, download video, second promise, timeout, like so. So we log in the result to the console. So for the error, so this logs our error using console.error, and we say logs request timeout after 2 seconds. Don't forget our delay period is 2 seconds. Okay, so we're invoking this here. So let's go I'm going to save this, and then let's go to our browser and let's see what we get. We get request timeouts. Let me refresh. See, request timeout. So that one wins because, well, after 2 seconds, when you what is it, this reject before this, because the delay period is 2 seconds, this one is 5 seconds. So the first responder wins. So even though we're passing the one that resolves as our first element in our array, or as our first promise, and then timeout as the second one, because this one it reaches the finish line first, so we're getting the error, the result, which is the error that says request timeout. So here we're logging the error here. So the timeout is the one that got to the finish line first. So that's why we're getting the error, request timeout, which is after 2 seconds. So that's for Promise.race, people. We can also look at Promise.any. For Promise.any, the first promise to resolve, it wins. Let's go here. Promise.any, first successful. That's what wins. So for Promise.any, so the first promise that resolved, that's the one that wins, right? But then there is a twist. Promise.any, it only cares about the first successful fulfilled promise. So if a promise rejects, it ignores it and then waits for another one to succeed. So this one is only concerned about success. So the first success, that's what wins. Okay. We also have we could have a catch, I think, if I'm not mistaken. Okay, we could have a catch. I'm going to uncomment this later, but let me do a little bit of explanation. So for the catch block, if the promise rejects, or if all of the promises in the array fail, then it throws an aggregate error. That's if all the promises in the array fail, then we get an aggregate error containing all the individual error messages. This is useful if we are querying in multiple replica databases or CDNs, and then we just want the fastest one to give us the data. So I'm going to comment this out again, and then I'm going to uncomment this, and then I'm going to explain what we have here. Okay, so this is what we have here. We have broken mirror. It returns a promise, this promise, and then inside this promise, where it rejects, and then inside our set timeout method function, in the callback, we call in the reject method function, and then we're passing the string server1 down. So the delay time is 500 milliseconds. The second function returns a promise, it returns a new promise, and then this one resolve, and then it returns a set timeout, and then in this callback we have we're calling the resolve function, and then we're passing this string inside here, and then the delay time is 1 second, like so. So to make use of these promises, we have this async function. We have the try catch block, and then here, okay, fast success. We have await Promise.any, and then we pass our array of promises here. Remember, the first one rejects, the second one it resolves. So we say console.log. We want to pass the fastest success here. So this is our data from server 2. Ignores the fast failure. Now, okay, I'm not. You realize that here the promise that rejects, the delay period is 500 milliseconds. So this is faster than this, which is 1000 milliseconds. So even though this rejects, this succeeds, it resolves. You realize that because this one is only concerned with success anyway, so it ignores the fast failure, the one that rejects, it ignores it, and then we get the success promise here. We can also log the error, that is the one that rejects. We get you get to log it inside this catch block. So I'm going to save this, and then we go to our browser. So I'm invoking this function here. So let's go to our browser. Okay. So I'm going to okay. So let's say data from server 2. So it didn't even log the error from the one that rejects. So this one is only concerned with success. Promise.any. So it only logged the success promise. It didn't even bother with okay, so this okay, so console.error, this we get this in the event that all rejects. That's when we get this. We get an aggregate error like I explained. So I'm just gonna play author this. So let's say this reject, for instance, reject, and then here I'm just going to, instead of resolve, I'm going to do reject, and then I'm going to say data from server 2 failed. Okay, and then I'm going to save, and let's see what we get. I think we're not going to get this. We're going to get a catch block here. So I'm going to save. Fingers crossed. Let's see. Okay, so it says all promises rejected. See, server 1 down, data from server 2 failed. So this is what we get. So I hope you guys have enjoyed this mini series. I'm going to see you guys the next video. Thanks for your time.